Welcome to QHSE Talks, the place where we cut through the noise and talk about what really matters for our planet and our future. You've heard the words climate change and global warming 1,000 times, but how much do we actually understand about what's happening and what it means for us? This episode takes you beyond headlines and into the facts, the real science, the rising numbers, and the global agreements shaping our response. From melting ice caps to economic shocks, we'll connect the dots between the environment, human health, and the systems that hold our world together. So stay with us, because understanding the story is the first step toward changing its ending.
It's so important we do. We're moving beyond just general awareness today. We need to get into the specifics, the quantification.
Right.
We'll look at the science history, the hard stats showing how things are accelerating, the systemic impacts, how it touches everything.
Health, finance, everything.
Everything. And then critically, the two main strategies for tackling it.
Yeah.
Mitigation and adaptation.
Okay, let's dive in. First things first, we need to get the language right. People often mix these up, right? Global warming versus climate change.
They do, and it causes confusion. They're definitely linked, very closely linked, but they aren't quite the same thing.
So let's unpack that. What's the core difference?
Okay, so global warming is specifically about the temperature rise. It's the recent and ongoing average increase in temperature near the Earth's surface.
The average part is key there.
It is. And crucially, the sources are clear. This warming is specifically caused by the buildup of greenhouse gases, or GHGs, from human activity.
So global warming is the heating mechanism driven by these gases. What about climate change then?
Climate change is, well, it's the bigger picture. It's defined as a statistically significant change in the state of the climate. Think average weather patterns that lasts for decades or even longer.
So it's not just about getting hotter everywhere.
Not necessarily. While the global average goes up, that's the warming. The effects vary hugely by region. You might get more intense heat waves somewhere, but maybe more flooding or even unusual cold snaps elsewhere. It's about the disruption of normal patterns.
Got it. So global warming drives climate change.
Precisely. And the sources really hammer this home. Human activities, mainly through emitting these GHGs, have unequivocally caused the warming we're seeing. The scientific certainty on that is overwhelming now.
Unequivocally, that's a strong word in science.
It reflects the strength of the evidence.
Okay, so let's talk about these GHGs, these greenhouse gases. What are the main ones we need to know about?
The most famous one, obviously, is carbon dioxide, CO2. That's mostly from burning fossil fuels, coal, oil, gas.
Right.
Then there's methane, CH4. It's much more potent than CO2 in the short term, actually. Comes from things like natural gas leaks, agriculture, livestock, landfills.
Okay.
Nitrous oxide, N2O, is another big one, often linked to fertilizers and farming. And ozone, O3, down near the ground, also acts as a greenhouse gas.
And you mentioned before we started, there's this whole other category, industrial gases. They don't get talked about as much.
Not as much in public discourse, maybe, but they are incredibly potent. These are synthetic chemicals, things like HFCs, PFCs, CFCs, HCFCs, and sulfur hexafluoride, SF6.
What are those used in?
Mostly things like refrigeration, air conditioning, electrical equipment, aerosols in the past. The amounts emitted are smaller than CO2, but molecule for molecule, some of them can trap thousands of times more heat.
Wow. So tackling those is a quick win, potentially.
A very significant one, yes. Phasing them out has a disproportionately large positive effect.
It's kind of amazing to think how long we've actually understood the basics of this. This isn't a new idea from the last few decades, is it?
Not at all. The deep roots go way back. The real breakthrough, you could say, was in 1896.
1896.
Yes, a Swedish scientist, Svante Arrhenius. He was the first to really connect burning fossil fuels, coal, mainly back then, to potential future warming. He actually calculated how much CO2 might raise global temperature.
That's incredible foresight. What else did he figure out?
Well, he also established the baseline, what we call the natural greenhouse effect. He worked out that the Earth's average temperature is about 15 degrees Celsius, which is habitable. And that warmth isn't just from the sun. It's because natural gases already in the atmosphere, like water vapor and CO2, trap some heat. Without them, Earth would be frozen.
So he set the stage. He understood the basic physics.
He did. His prediction for how fast it would warm up was off. He thought it might take thousands of years. He couldn't imagine the sheer scale of 20th century industrialization,
Understandable. When did the science really start firming up after him?
There were key steps mid-century. In the 1940s, scientists confirmed experimentally that more CO2 in the air does absorb more infrared radiation, more heat.
Okay.
Then, in the 1950s, they figured out that CO2 actually stays in the atmosphere for quite a while. It doesn't just vanish.
Yeah.
Early estimates were around 10 years, but we now know parts of it persist much, much longer.
So the pollution, it builds up.
It accumulates. That's the problem.
Given this long history, why was there so much public debate and, well, controversy, particularly in the 1990s?
Yes. The sources point to genuine scientific uncertainties back then. Early climate models were less sophisticated. They struggled with complex factors like clouds, aerosols, ocean currents.
Which created room for doubt.
Exactly. It created space for legitimate scientific questions, which unfortunately was sometimes exploited for political reasons. But the science itself was still evolving.
And what led to the current consensus? You said it's nearly unanimous now.
Decades of more research, basically. Much better data, especially from satellites monitoring the whole planet, and vastly more powerful computers for running climate models.
So the models got better, the data got better.
Exponentially better. The evidence linking the observed warming directly to the rapid increase in human-caused CO2 emissions just became undeniable. The signal emerged clearly from the noise.
Right. And since this is a global problem, it needs a global response. That brings us to things like the Kyoto Protocol and the Paris Agreement.
Yes, the international frameworks. Kyoto, back in 1998, was the first major attempt at legally binding targets.
What was its main goal?
It focused on developed countries, requiring them to cut a basket of greenhouse gases, CO2, methane, N2O, and those industrial gases we mentioned, by an average of about 5% below their 1990 levels.
And they had a specific time frame.
Yes. The first commitment period was 2008 to 2012. It was a huge diplomatic effort, signed by 186 countries by 2001, though famously, the U.S. didn't ratify it.
Right. Then came the Paris Agreement in 2015. How did that change things?
Paris was different. It shifted to a more bottom-up approach. Every country sets its own targets, called nationally determined contributions, or NDCs.
But it set those crucial temperature goals, didn't it?
It did, and that's its enduring legacy. Two main targets.
Okay.
First, hold the global temperature increase to well below 2 degrees Celsius above pre-industrial levels.
Below 2 degrees.
And second, pursue ambitious efforts to limit the increase even further to 1.5 degrees Celsius.
That 1.5 number is everywhere now.
It's become the benchmark. It's widely seen as the threshold beyond which climate impacts become significantly more dangerous and potentially irreversible for many systems.
Okay, so that's the goal. Try to stay below 1.5 degrees. Now, let's get into the numbers, the quantification. How are we actually doing? This is where the sources get, well, pretty sobering.
They do. The rate of change is just unprecedented in human history. Look at the long view. Since 1970, the global surface temperature has gone up faster than during any other 50-year period in at least the last 2,000 years.
2,000 years. That covers, like, the Roman Empire, the entire medieval period. All of that was relatively stable compared to the last 50 years.
Climatically speaking, yes. We've slammed the accelerator on the planet's thermostat in what is geologically the blink of an eye.
And the recent records really underscore this. The sources flagged 2024 specifically.
Yes. The data indicates that 2024 was extremely likely the first full calendar year where the global average temperature exceeded 1.5 degrees Celsius above the pre-industrial average.
The first year over 1.5 degrees.
Specifically, the estimate is 1.5 degrees, plus or minus about 0.13 degrees, compared to the 1850-1900 baseline.
Okay, wait. If the Paris goal is to limit warming to 1.5 degrees, and we've already hit it for a year, does that mean Paris has failed?
That's a really important clarification. No, not technically. The Paris target refers to a long-term average, usually over 20 or 30 years, to smooth out natural variations like El Niño.
So one warm year doesn't mean we've permanently failed the goal.
Correct. But hitting 1.5, even for a single year, is a massive warning flare. It shows how incredibly close we are to breaching that long-term limit. It means the buffer zone is basically gone.
It tells us the direction we're heading fast.
Alarmingly fast. And look at the trend over the last decade. Every single year, from 2015 to 2024, is among the 10 warmest years ever recorded. It's not just one hot year. It's a relentlessly warming trend.
Okay, let's link this back to the greenhouse gases. What are the concentration levels looking like?
Again, the numbers are stark. Remember, the increases since about 1750, the start of the Industrial Revolution, are unequivocally human-caused.
Right. No natural cycle explains this.
None whatsoever. For CO2, in 2023, the atmospheric concentration hit 419 parts per million ppm.
How does that compare to pre-industrial times?
It's 151% of the level in 1750. So we've added 50% more CO2 on top of the natural level, But here's the kicker.
Go on.
Current CO2 concentrations are higher than they've been at any point in at least the last 2 million years.
2 million years. That's hard to process. That predates modern humans. Right?
Way before Homo sapiens evolved.
Yeah.
For our entire species history, we lived in a world with fundamentally lower CO2 levels. We've altered the atmospheric chemistry on a geological timescale in just a couple of centuries.
And it's not just CO2, is it? Methane, nitrous oxide.
Same story, essentially. Concentrations of both methane and nitrous oxide are also at levels unprecedented in at least 800,000 years, based on ice core data. We're pushing multiple buttons on the climate control panel simultaneously.
It's like we're running a planetary experiment without knowing the full consequences.
A very risky one.
Now, a lot of this extra heat isn't staying in the atmosphere, right? The oceans are absorbing a huge amount.
A truly massive amount. The sources state the ocean has absorbed something like 91% of all the extra heat trapped by greenhouse gases.
91%. That's incredible. What does that do to the ocean?
It warms it up, obviously. Ocean heat content hit a record high in 2024. Looking back over the 65 years, we have good observational data. And actually, each of the last 8 years has set a new record for ocean heat.
So the ocean is acting like a giant heat sink, slowing down atmospheric warming, but at a cost to itself.
Exactly. It buffers us, but it fundamentally changes marine ecosystems, ocean currents, and crucially contributes to sea level rise.
Ah, right, because warmer water expands.
That's part of it, thermal expansion.
Yeah.
The other major part is meltwater pouring in from glaciers and ice sheets in Greenland and Antarctica, which are melting because of the warmer air and warmer ocean water.
And is sea level rise accelerating too?
Yes, and the acceleration is really clear in the satellite data. Between 1901 and 2018, the global average sea level rose by about 0.2 meters, or 20 centimeters. But the rate of rise has more than doubled recently. If you compare the early satellite era, say 1993 to 2002, the rate was about 2.1 millimeters per year.
Right.
But in the latest period, 2015 to 2024, it jumped to 4.7 millimeters per year.
More than double the speed in just 2 decades.
Yes. That has huge implications for coastal communities, infrastructure, erosion. The timeline for adaptation is shrinking fast.
It really changes the game for planning, doesn't it? Decades suddenly become years.
It does. And speaking of responsibility, we need to touch on where these emissions are coming from. Is it evenly spread?
The sources had a pretty stark statistic on that.
Yeah, the global footprint is very unevenly distributed. The top 10 emitting countries are responsible for about 68% of global greenhouse gas emissions.
2/3 of the problem from just 10 countries.
Broadly, yes. It highlights that while it's a global problem, the bulk of historical and current emissions comes from a relatively small number of major economies.
And what's the total amount we're pumping out each year globally?
The estimate for 2019, which is a recent benchmark year, was around 59 gigatons of CO2 equivalent, that's written as GTCO2 plus or minus about 6.6 gigatons for uncertainty.
59 gigatons. Can you, put that number in perspective? What does a gigaton even mean?
It's huge. A gigaton is 1 billion metric tons. Imagine. Maybe 1 million large elephants. Now imagine 59,000 times that weight in invisible gas being added to the atmosphere every single year.
Okay, that helps visualize the scale. It's an immense weight of pollution altering the planet's energy balance.
That's exactly what it is.
Right. So with that sheer scale of emissions fundamentally changing the climate system, the consequences inevitably ripple outwards. Let's talk about those cascading effects. It's not just about temperature, is it?
Not at all. Climate change basically acts as a threat multiplier. It takes existing vulnerabilities, weather extremes, ecosystem fragility, social inequalities, and makes them worse.
So more extreme weather.
Definitely. We're already seeing it. More frequent and intense heat waves across most land areas. That's been happening since the 1950s. More intense rainfall leading to floods in some places, deeper droughts and desertification in others. Excessive snowmelt causing spring flooding. It disrupts the entire weather system.
And the projections for the future, particularly around water, they sound chaotic.
They point towards increased variability and intensity. The global water cycle gets supercharged. Essentially. It means areas prone to monsoons might see even heavier rainfall, increasing flood risk, but simultaneously, dry regions could face longer and more severe droughts. It's like the whole system becomes more volatile, swinging wildly between extremes. Very wet and very dry events become more common.
That sounds incredibly difficult to manage.
Extremely, especially for agriculture and water resource planning.
And what about the impact on nature itself? Ecosystems, biodiversity.
This is where some of the most worrying and potentially irreversible impacts are happening. The sources highlight coral reefs as a prime example.
Right, you mentioned those earlier. The projection was devastating.
It is. Even if we do manage to limit warming to 1.5 degrees, scientists project that 70 to 90% of tropical coral reefs will still be lost.
70 to 90% gone, even at the best case Paris target.
Yes, and if warming goes higher, towards 2 degrees or beyond, they could essentially vanish entirely.
And that's not just sad for snorkelers. Reefs are vital nurseries for fish. They protect coastlines.
Exactly. Losing them has huge ecological and economic consequences for millions of people. And it's not just reefs. Increased warming raises the risk of mass extinction events and irreversible biodiversity loss across the board. Think about forests stressed by drought and fire, or the unique Arctic ecosystem rapidly transforming as ice disappears.
It's like pulling threads from a complex tapestry. Things start to unravel.
That's a good analogy. The climate crisis and the biodiversity crisis are deeply intertwined.
Okay, let's shift to the direct impacts on us, on human systems. This is a major health crisis too, isn't it?
Absolutely. Both physical and mental health are being affected.
How so, physically?
The most direct is increased illness and death from extreme heat stroke, cardiovascular stress, especially for vulnerable populations. Then there's the spread of diseases.
Diseases.
Yes, climate change affects the range of insects like mosquitoes and ticks that carry diseases like malaria, dengue fever, Lyme disease. Warmer temperatures and changing rainfall patterns allow them to thrive in new areas. We're also seeing higher risks from waterborne and foodborne illnesses due to contamination after floods or temperature changes affecting pathogens.
And the mental health aspect, that's getting more attention now too.
As it should. There's growing evidence of increased anxiety, stress, and depression linked to climate change, sometimes called climate anxiety. Plus, there's the direct trauma experienced by people who live through extreme weather events, lose their homes, or face displacement. It takes a significant mental toll.
And tied into all of this is the economic cost. The sources mentioned a staggering potential loss, $23 trillion by 2050.
That's one prominent estimate, yes. It tries to quantify the potential global economic damage if climate change continues largely unchecked.
What kind of losses does that $23 trillion figure include?
It's a whole range of things. Lost worker productivity because it's too hot to work safely or efficiently. Damage to buildings, roads, power grids from storms and sea level rise. Crop failures due to drought or floods hitting agriculture. Increased healthcare costs. Disruptions to global supply chains. It's the cumulative economic drag caused by a destabilized climate.
And presumably that cost isn't shared equally either.
Not at all. Which brings us squarely to the issue of climate justice.
Explain that term.
It highlights the deep inequity of the crisis. The data shows that the poorest communities and nations, who have historically contributed the least to the greenhouse gas emissions causing the problem, are often the ones hit hardest by the impacts.
How does that play out?
They often live in more vulnerable locations, have fewer resources to adapt or rebuild after disasters, and rely more directly on agriculture or natural resources that are climate sensitive. So, climate change leads directly to loss of homes, livelihoods, food security for them, often forcing people to migrate, becoming climate migrants or refugees.
Which creates further instability and pressure elsewhere.
Exactly. It's a vicious cycle.
This really underscores how climate change isn't just an environmental issue in isolation. It connects to almost every other major challenge we face.
It's a connector of crises, absolutely. Take air pollution.
How are they linked?
Well, often the source is the same. Burning fossil fuels causes both CO2 emissions and harmful air pollutants like particulate matter and nitrogen oxides. So when you take action to reduce CO2, like shifting to renewables or cleaner transport, you also get immediate improvements in air quality and public health. It's a co-benefit.
The win-win.
Yes. But conversely, climate change can make air pollution worse. Heat waves, for example, can accelerate the chemical reactions that form ground-level ozone, or smog, especially in cities.
Okay. What about the links to water and land?
We touched on water scarcity. Climate change messes with the whole water cycle, impacting both the quantity and quality of water available. Sources say about half the world's population already faces severe water scarcity for at least part of the year. Climate change makes that worse.
And land degradation.
It contributes significantly to desertification, especially in dry regions, and makes land degradation worse globally. This is about soil losing its ability to support life, often due to drought, combined with unsustainable farming or deforestation. It directly impacts food security.
And all of this hinders broader development goals, right? Like the UN Sustainable Development Goals.
Absolutely. It makes achieving goals related to ending poverty, hunger, ensuring clean water much harder. But, and this is important, the sources also highlight a potential synergy.
How so?
If climate action, both mitigation and adaptation, is done in a way that is inclusive, equitable, and focused on justice, it can actually help achieve those SDGs. Things like promoting renewable energy access can lift people out of poverty, sustainable agriculture improves food security, empowering women in climate solutions advances gender equality.
So climate action isn't just about stopping the bad stuff. It can be a vehicle for positive development if done right.
Precisely. It's about building a more resilient and more equitable future.
Okay, so we've established the problem's scale, the alarming trends, the cascading consequences. Now let's focus on the solutions. The sources lay out this essential dual strategy: mitigation and adaptation. Let's break those down. Mitigation first, what does that entail?
Mitigation is all about reducing the source of the problem, cutting greenhouse gas emissions to limit future warming.
The number one priority there has to be energy, right?
Absolutely. The core of mitigation is a massive energy transition. That means rapidly phasing out fossil fuels, coal, oil, and gas, especially when they're used without technology to capture the carbon emissions, known as carbon capture and storage, or CCS.
So shift away from unabated fossil fuels. Towards what?
Towards very low or zero carbon energy sources. Primarily that means renewables like solar and wind, which have become much cheaper. Nuclear power also plays a role, as does using fossil fuels if paired with effective CCS, though the deployment of CCS at scale is still challenging and debated.
That's the big supply side change. What about using less energy in the first place? Efficiency.
Hugely important. Efficiency measures are often the cheapest and fastest way to cut emissions. Simple things. Scaled up. Replacing inefficient incandescent light bulbs with LEDs. Drastically improving insulation in buildings to cut heating and cooling needs using more efficient appliances. Just reducing energy waste across the board.
Makes sense. What else falls under mitigation?
Land use is critical. Protecting existing forests, especially tropical rainforests, which are huge carbon stores, and actively planting new trees and restoring degraded lands, afforestation and reforestation. Stopping deforestation is key.
Enhancing the natural carbon sink.
Exactly. And then there's the whole area of demand reduction. This is about changing how we live, consume, and move.
And the sources suggested this has massive potential.
Potentially enormous.
Yeah.
Estimates suggest that changes in demand and how we use energy, transport, food, materials could cut global GHG emissions in the sectors where we use energy by something like 40 to 70% by 2050.
40 to 70%, that's a huge slice. What kind of changes are we talking about?
It involves some fundamental shifts, moving away from private cars towards public transport, walking, and cycling, promoting car sharing, and accelerating the shift to electric vehicles.
Okay.
On the consumption side, a big one is reducing food loss and waste. About a third of all food produced globally is wasted, and that has a massive carbon footprint from production, transport, disposal.
So just wasting less food helps the climate.
Significantly. And also shifting towards more sustainable and healthy diets, typically meaning less red meat, especially from intensive farming, and more plant-based foods sourced locally where possible.
That touches on industry and waste too, doesn't it? Methane from landfills, industrial processes.
Yes, tackling methane leaks from the fossil fuel industry, coal mines, oil and gas wells is vital because methane is so potent short-term. Reducing methane from landfill waste through better management and capturing the gas is also important. Encouraging recycling and shifting industries towards greener processes, like using hydrogen instead of coal for steelmaking, are all part of it.
It sounds like even with all that, getting to absolute zero emissions might be impossible for some sectors. What do we do about the unavoidable remainder?
That's where carbon dioxide removal, or CDR, comes in. This refers to actively pulling CO2 out of the atmosphere.
Pulling it out? How?
It can be done through natural methods, like planting more trees or enhancing carbon storage in soils, or through technology, like direct air capture machines that essentially filter CO2 from the air. CDR is seen as necessary to balance out those hard-to-abate residual emissions, perhaps from things like long-haul aviation or cement production, to actually reach net zero.
Okay, so that's mitigation, stopping the problem from getting worse. Now, what about adaptation? Dealing with the changes already happening or locked in?
Adaptation is about adjusting to the current and future effects of climate change to minimize the harm. It's about building resilience.
What are the key approaches there?
One important strategy is using ecosystem-based approaches. This means using nature and healthy ecosystems as part of the solution. Things like restoring wetlands or mangroves along coastlines to protect against storm surges and erosion. They often work better and cheaper than concrete seawalls. Planting trees and creating green spaces in cities, urban greening, helps cool them down during heat waves and can manage stormwater runoff. Restoring forests in upstream catchment areas can reduce flood risk downstream. It's about working with nature.
That makes a lot of sense. What about our built environment, infrastructure?
Critical. We need to make our infrastructure, roads, bridges, power lines, water systems, more resilient to extreme weather. That might mean building seawalls higher, designing buildings to withstand stronger winds or higher temperatures, ensuring energy and water supplies aren't easily knocked out. It also means integrating climate risk into all planning decisions, like not building critical infrastructure in known flood zones.
And what about protecting people directly, especially during disasters?
That involves better information and health tools. Things like improving disaster risk management, rolling out effective early warning systems, EWS, for floods, storms, heat waves, so people have time to prepare or evacuate. Developing specific heat health action plans for cities to protect vulnerable people during extreme heat events.
And basic needs.
Ensuring access to safe drinking water, improving sanitation, and strengthening health services to deal with the increasing burden of climate-sensitive diseases we talked about earlier. Adaptation is very much about protecting human well-being in a changing climate.
Okay, we have the dual strategy. Cut emissions drastically, mitigation, and prepare for the impacts, adaptation. But the sources are clear that we need to accelerate action, like yesterday. What are the urgent recommendations?
The absolute top line is the urgency of keeping that 1.5-degree goal within reach. It requires immediate, rapid, and sustained emission cuts across all sectors. Governments, businesses, individuals, everyone needs to step up now.
And the sources stress that every little bit of warming matters.
Critically, it's not like 1.5 is safe and 1.6 is disaster. It's a gradient. Every fraction of a degree we go beyond 1.5 significantly increases the risks, the costs, the suffering, especially for the most vulnerable parts of the world. There's no safe level of warming anymore, really.
This kind of transformation sounds expensive. What about the money?
That's a huge challenge. The sources point to a massive financial gap. The amount of money needed each year for mitigation alone is estimated to be somewhere between 3 to 6 times greater than what's currently being invested globally.
3 to 6 times more money needed every year.
Yes, it's a colossal sum. Closing that gap requires fundamental changes in global finance. We need much more public and private investment flowing into clean energy and climate solutions. And crucially, that financial support needs to reach developing countries and vulnerable groups who need it most for both mitigation and adaptation.
So it's not just about finding the money, but directing it effectively and equitably.
Absolutely. And policy is key to making that happen. We need integrated, clear policy packages from governments.
Like what kind of policies?
Things like putting a price on carbon pollution, either through taxes or emissions trading systems, ending subsidies for fossil fuels, actively subsidizing renewable energy deployment, setting strong energy efficiency standards for buildings and appliances, supporting international environmental standards that are legally binding. Policy needs to make the clean choice, the easy and economic choice.
And throughout all this, the sources kept emphasizing equity and justice.
It has to be central. If climate action isn't fair, it won't be sustainable or effective in the long run. Actions need to prioritize equity, climate justice, and social justice.
How do you ensure that happens in practice?
It means using inclusive processes, actively involving local communities, indigenous peoples, women, marginalized groups in decision-making, recognizing and incorporating traditional and local knowledge alongside scientific data. For instance, indigenous communities often have deep place-based knowledge about managing resources sustainably or adapting to environmental change that can be incredibly valuable.
So it's not just top-down policy, but bottom-up engagement.
Both are essential.
What about the role of individuals? It can feel overwhelming, like the problem is too big. What can people actually do?
The sources stress that everyone does have a role. First, just getting informed. Understand the basics. Challenge misinformation when you see it.
Okay.
Then look at consumption patterns. Can you buy less stuff? Buy secondhand. Reduce plastic use. Minimize food waste. Support local and sustainable producers where possible.
Changes in lifestyle.
Exactly. And transportation choices, using public transit, cycling, walking more, considering car sharing or electric vehicles if feasible, supporting businesses and organizations that are genuinely committed to sustainability and climate justice, advocating for stronger climate policies from governments. Individual actions add up, and they also send signals to businesses and policymakers.
And supporting those most affected, like climate migrants.
Yes, supporting organizations working on climate justice, aiding climate migrants, supporting the rights and livelihoods of indigenous peoples who are often on the front lines of both impacts and solutions.
To make this governance aspect more concrete, the sources included a specific example about monitoring in Egypt. How does that illustrate the point?
It shows how national policy translates into on-the-ground action and accountability. The sources mention that data is available on Egypt's emissions by sector, per capita emissions, etc.
Right.
But the key mechanism is their environmental law, specifically Law 4 from 1994 and its updates. This law requires every industrial facility in the country to create and maintain an environmental register.
An environmental register, what's that?
It's essentially a detailed logbook.
Yeah.
The facility has to track its resource use, its waste generation, its pollution outputs, its emissions. It forces them to monitor their own environmental performance against legal standards.
So it's a tool for compliance and tracking.
Exactly. It's the basis for environmental management systems, EMS, at the company level. It connects the national environmental goals to the actual operations of individual factories or plants. It makes environmental performance measurable and legally accountable at the local level.
So it's that local level monitoring and enforcement mandated by law that really makes a difference, not just signing international treaties.
You need both, of course. But yes, the domestic laws and the systems for monitoring, reporting, and verification, MRV, are what ensure that national commitments actually lead to changes on the ground. Continuous monitoring and follow-up are crucial. #outro.
Well, we have covered a huge amount of ground in this deep dive. We've gone from Arrhenius back in 1896, spotting the potential problem, all the way to the stark reality of 2024, likely breaching that 1.5-degree threshold for the first time.
Yeah.
We've seen the cascading impacts, the threat to ecosystems like coral reefs, the intensified floods and droughts, the immense economic risks, the health crises, and we've looked at the sheer scale of the response needed, that dual track of deep mitigation and widespread adaptation.
And I think the core message that comes through is that while technology is part of the answer, it's not enough on its own. The solution really lies in getting the policy right, mobilizing the necessary finance, and ensuring it's all done in a way that is fundamentally fair and just.
Which leads us perfectly into the final provocative thought we want to leave you with today, drawn directly from that financial challenge we discussed. The sources state that mitigation investment needs to increase by 3 to 6 times current levels, a truly monumental sum.
Yeah, staggering.
So the question for you to ponder is this. As the world scrambles to mobilize trillions of dollars for climate action, how can we possibly ensure that this massive influx of cash actually prioritizes equity? How do we make sure it truly benefits the vulnerable communities who did the least to cause this crisis but are suffering the most?
That tension between the urgent need for massive, rapid investment and the fundamental requirement for climate justice, that's really the defining challenge for the next phase of global climate action, isn't it?
Something for all of us to think about. Thanks for joining us on the Deep Dive.